In this third part of lecture on project management, we will talk about how we can use some strategies to mitigate some of the problems we talked about in the earlier lectures. We're going to look at three specific antidotes, and let's go over each one of them. The first one is to discover a project's true business purpose, and the second one is to look at ways to curb scope keep, and finally to build in accountability without micromanagement. So let's start with the first one, which is discovery of purpose. And IT projects traditionally follow a sequence of activities, and the traditional way, this is called the waterfall approach, and the sequence of activities are gathering requirements, then you go into design, then you go to code, testing, and then you have the rollout. And in the old traditional model, which is still followed by a lot of companies, this design, code, and testing really have no involvement from the users or non-IT people. That they are, the line managers are involved in the gathering requirements phase, and then they use it right here in the rollout. And any issues creeping up here, this is kind of called the window of isolation, because there is no input here. And sometimes it could take years when the first contact is done, and then when they finally get the product. So we talked about latent needs, which could creep in here, flawed requirements, and during this time, business needs change, competitors react, technology evolves, regulations changes, and the problem is that the waterfall model wrongly assumes that a project team can identify business users' latent needs at the outset, that is one, before the shaded region. The risk in pressuring business users to articulate their needs early on is that they might over-specify project requirements or a solution, and the project team is likely to give them what they ask for, but not necessarily what they need. This dramatically increases the risk of building a system around a flawed, incomplete understanding of business needs. The textbook term for this first step is called requirements elicitation or requirements gathering, user requirement specifications, and essentially it caricatures business users as a turnip out of which a programmer must squeeze out requirements. This term is even disingenuous to the spirit of IT line relationship as a two-way conversation, which we've talked about throughout this book. So a lot can also change during this window of isolation, as we talked about, and there is very little interaction during this phase. Line functions, business needs change, competitor might alter strategies, technology can evolve, regulatory agencies could post new rules, and if a new requirement was identified during this window of isolation, the waterfall approach requires redoing at huge cost the work done in all the complete stages. So the waterfall model just simply lacks flexibility to hit a moving target and the mechanisms to incorporate feedback. The completed project then meets the business need that the firm once possibly had in the past, but not the ones it has right now. And this leads to project obsolescence even before it's completed. So we're kind of looking at the lean approach to managing IT projects, and lean is a manufacturing word, but IT has often used the word agile for that. And so this is a rival philosophy to project management. And the more technology term is agile methodologies. Lean approach assumes two things that put business users in the center of the project. First, Future users find an IT project requirements difficult to articulate upfront. You cannot tap on a future user's shoulder and ask them what they want and expect to get good answers. You must integrally engage them to discover their latent needs. Second, their requirements will change over time. A project's value in the lean approach is in the eyes of its user. It is successful only if they find it useful. People come before technology. And so you hear words like Scrum, extreme programming, pair programming, or prototyping, and they're all permutations of these three foundational principles. If you grasp these three, you can make sense with any sense of lean or agile technologies. Okay, so we talked about active business participation, short iteration, and less code. So let's look at the first ideal of active business participation. The business users have domain knowledge, and the IT unit has technical knowledge, and this converges to figure out what your prioritized requirements are. You don't need communications channel between IT and line functions when business users are in the project team. They are the channel. Active business participation, therefore, increases the prospects that a project will deliver intended business benefits. Lean approaches, therefore, often designate a non-IT manager from a line function as project owner. This is neither the project manager nor the project sponsor. And the side effect of this active business involvement is the IKEA effect. Building something yourself fosters ownership, no matter how imperfect it is. IT projects often fail to deliver business value because a build it and they will come mindset often pervades IT units. A finished system cannot deliver any business benefits if people don't use it. An unused IT system is an expensive paperweight, and getting people to use a rolled out system involves the human side of IT. So when you look past the technology itself, IT projects intentionally attempt to change how people in line functions do their jobs. And this change threatens to wipe out their attained skills in using the old systems. And if you mandate the use of new systems, users often find creative ways to circumvent it and resist it even more. The resistance is rarely to do with new technologies, but actually the impact it has on their job security and power. Getting line function employees to use a new system requires better than just a better mousetrap. It requires their buy-in. And buy-in comes from active participation in a project they helped create, makes them more likely to champion its use in their line functions after rollout. They develop a personal stake in its success. A project's non-IT team members are credible messengers to emphasize how their colleagues will personally benefit from using it. And so this business side participants in an IT project team we're looking at five attributes which can be remembered by this mnemonic crack. It's collaborative, representative of business users, authorized to decide, make decisions, committed to business value, and they're knowledgeable to their line functions, operations, and business process. So this is important for active business participation. The second idea, the lean idea, is short iterations. So if you do the project as a series of iterative sprints of 2 to 6 weeks each iteration hands over to the user a crude but functioning version of the system with only a small subset of the project's functionality. Feedback here, then on a prototype in the user's hand is worth more than 1,000 presentations. When they see the intermediate prototype, they can tell the project team whether what they see is what they want and what is missing. And this iteration forces IT designers to repeatedly test their own beliefs on what users want and correct the inaccuracies in their own understanding. It reduces the lag between discovering a user need and addressing it in a project. Working features then become project milestones, and the user's environment becomes the project's laboratory. So instead of doing a single marathon, we have multiple sprints, and this ends up having a two-way conversation. These iterative sprints also help in bringing out some of the latent requirements. When the users are using this crude prototype or system, they actually figure out what they actually want. So it uncovers latent needs, and it clears up misunderstandings earlier, which makes it cheaper to fix that than later in the process. Now, this is very similar to a process called concurrent engineering from the engineering and manufacturing. And concurrent engineering was similar when people used to engineer products, and they used to kind of use this whole waterfall model where it went from one department to another, and by the time the finished product happened, there were multiple times when the product went back, and instead of building a project team and putting all the inputs right there. So this is very similar to concurrent engineering, which is an old concept. The final lean idea is essentially using less code. Reducing the amount of software code in the system is important because the chance of errors increase with the number of lines of code. So every line of code explicitly justified with business objectives, and this bakes in quality and curbs cost in two ways. Software with more code is more buggier, and so it's very important to have less code makes it easier to build in quality there. Historical data shows the average programmer makes 10 to 15 errors in every 100 lines of code. So even the most rigorous testing can catch about 50% of them. A small million-line piece of software will have 10,000 errors, of which 5,000 errors remain undetected before release. So more code, more error. The cost of fixing the error is 100 times greater than the software deployed. So Toyota had a breaking software glitch that cost the company $10 billion in repair costs. Also, lesser code lowers upfront development costs because that's less lines of code. So if you implement the 80-20 rule, which is essentially 20% of the requirements satisfy 80% of the needs, and you do short iterations, this will actually help. So other lean enabling ideas is constant automated testing, and continuous integration reduces integration glitches at the end. And so these are all part of a part of the lean idea. And continuous integration is something that automatically runs every night to fit together all the project team members' days' work. And automated testing takes out the grunt work out of testing, and continuous integration eliminates surprises from misfitting parts at the end of the project. So this here, we look at lean payoffs. When we have active business involvement, we build the right system, we have short iterations, we can essentially have short iterations make it cheaper and faster, and also the less code brings in cheaper and faster, and finally less code bakes in quality. So you are moving towards the three area where you can have better, faster, and cheaper, and this gets the business value is more likely to come out of this process than the waterfall model. So let's look at some historical data from this process. We're going to look at small projects and large projects, and you can see that in gray you have the waterfall model. That's gray, and in lean is using the lean method is the blue bars, And you can see in small projects, lean is more successful. They have less failures and less ones which are challenged, which are in trouble. But you also see that no matter whether you have when you have large projects, it's more likely to be challenged or fail, whichever methodology you use. And so it's better to break these large projects up into smaller projects. So you look at this, even with lean methodology with large projects, only 20% succeed, whereas 58% are successful when you are doing small project. So the whole approach essentially looks at breaking up these smaller projects into, bigger projects into smaller projects. Lean methodology does not mean that the waterfall model does not have its place. A mismatch between project and the choice of lean versus waterfall unnecessarily increases project risk. Waterfall method can kind of be used when you have stable requirements, proven technology, and you, especially in infrastructure projects, the waterfall methods could be more appropriate. And as we talked about, larger projects are always more challenging. The second antidote and one of the biggest threats to IT projects has always been trying to do too much, too often, too fast with too few resources. Trying to cover 100% ground can mess up 20% that matters most to your business. The only way to prevent such complexity from overwhelming a project is to focus on one or two really important business ends that you hope your project can achieve. You can tame a project scope by using the 80-20 rule. The heuristic that 20% of the project features can meet 80% of the business needs. A system that gets this 20% right is what Herbert Simon would call satisficing, good enough to be acceptable. The tricky question is which 20%. Non-IT managers can help identify the 20% by classifying each of the major project requirements into one of the four categories. And it's colloquially called the Moscow category. Must have, should have, could have, but it's not critical. Won't have this time, but maybe later. Usually must have are about 20% requirements that the project must prioritize. Such prioritization focuses the project team and ensures that the line function do not make impossible demands. Ideally, the ranking must be a consensus of all line functions that have a stake in the project. This prioritization project makes it explicit what the project is not trying to do. Lower priority requirements can become later sub-projects, and they are the may-do projects in real options thinking we have talked about earlier. An explicit consensual prioritization of requirements by business users safeguards projects against scope creep, and that leads to unnecessary complexity. So, example is one line function requesting additional functionality after development is already under the way. Adding more people to a project team, however, is not an antidote to complexity. Adding more people only makes a late project later, and there are more people to bring up to speed and coordinate. And this is very important for line managers to understand. A lot of times in my IT consulting and implementation and development, I've often heard the term when we talk about a project and say, well, it takes about, this is a year for 15-person group to finish. And they often say, well, then put 30 people and finish it in half a year. It's not linear. You've got to understand in a project, there are too many connecting parts, and everything cannot be done in parallel, and it's not as linear as people think it is. A side benefit of this business-driven proposition is that a project is more likely to gain upper management support. The third antidote is accountability without micromanagement. There are two ways to judge a project's success. First, was it executed well in terms of schedule, budget, and quality? Second, did it deliver the desired business results measured by operational business metric, which we talked about in the fourth chapter? Many IT projects falter in the second aspect when non-IT managers are not involved at a few critical junctions. So it is the non-IT managers' task to hold the team accountable for delivering business benefits. Such benefits are a project's measurable organizational value, and this must come from the line functions, business side rather than the IT unit. Begin with the intended impact and emphasize desirable outcomes and not features. Any measurable organizational value deserves a cold, hard look at how it will further your operational strategy. This value has to be measurable to your organization, and an MOV statement for any IT project must have four elements. Intended impact, operational, strategic, or financial. Promise, will it help do something better, faster, or cheaper? Changing the metric, dollars, percentage, or time. Time to impact after the project has completed. Details of how you achieve MOE do not belong in the MOE statement. If a project's entire measurable organizational value cannot be expressed in one line, its scope is too scattered. So let's try making your project's MOE pass a tweetability test, right? By fitting it into a short sentence structured project X will promise the targeted impact by changing a metric within time. So good example is project X will increase inventory turnover in our US stores by 1.6 days within 2 years. And here are some bad examples. Create ubiquitous new challenge to target mobile customers through real-time analytics. Will strengthen our ability to deliver an industry-leading experience to customers. Very vague. And if you lower distribution costs by 10%, lower IT costs by 10% by rationalizing our global platform, will implement the Obamacare law. Again, these are too broad, too vague. And so specific, as we talked about, again, let me repeat a good example. Project X will increase inventory turnover in our US stores by 1.6 days within 2 years. So developing the project's measurable organizational value should collaboratively involve all project stakeholders. The contributions of diverse project stakeholders help balance on what's ideally desirable and what's realistically achievable. Project teams should also be informed upfront that this is how the project's ultimate success will be judged. Creates accountability for delivering business results without micromanaging how IT units will execute the project. The bottom line is that any IT project must have clear non-IT ownership of what business objectives it will achieve and clear IT unit ownership of how it will, and then coupled with mutual accountability. This holds the IT unit responsible for the project's business results without dictating how they need to do their work. MOV-centric approach rather than overemphasizing technical metrics ensures that your IT employees are evaluated first as business people. So if you look at the overarching theme in these three antidotes to the business failure of IT projects are you are making projects smaller and actively involving business stakeholders. Finally, we'll talk about 3 different rollout strategies, and a poorly chosen rollout strategy can hurt users' receptivity and potentially jeopardize the business payoff. And this is something while this seems really common sense, this is something IT units often don't pay a lot of attention to. So here are three rollout strategies. First one is called direct cutover. You have the old system and then you move to the new system. The old one is turned off, the new system is turned on. It is a very risky strategy. It is cheaper, but it's risky because you have a widespread impact of glitches and definitely needs to be avoided for mission critical IT systems. Direct cutover is appropriate if old system is unusable, remember Y2K, and if the new system is not mission critical to your firm's core operation. Then we have something called a parallel rollout. We have the old system, and then somewhere in the middle we start the new system, we run both of them together simultaneously, and so there's a safety net for glitches, but it prolongs rollout period, and this is a problem for users. Remember, now you are asking users to continue with their work on the old system and learn the new system simultaneously, which means they have to input data twice. Most likely they're actually inputting the data twice because there isn't the migration may not be perfect at this time. However, business pressures of getting a new system quickly up and running don't make it very feasible. And the last one is the phased rollout again. So we break this into multiple chunks. And so in this particular case, maybe a department or an area starts with a system, the old system continues running, and then we move on to the next department, and then finally the old system is shut down because we do it at bite-sized chunks of functionality. And again, here the business pressures of getting a new system up and running actually a lot of times don't allow this phased rollout, but this is really one of the safest ways of doing it. Bad choices, of course, hurts receptivity and jeopardize payoffs. And it is important for companies to think very carefully about their rollout strategy. So to summarize this chapter on project management, we talked about how IT projects have really dismal success rate with the trifecta, which is amplifying the business penalties. And even if the project is a technical success, it can be a pretty bad business failure. And we talked about the three causes: ambiguous business goals, unneeded complexity, and non-IT managers not really prioritizing whether between the cheap, fast, and good. We talked about three antidotes to it: discovering latent business needs, curbing the scope, and having accountability without micromanaging. We talked about how lean methodology beats waterfall unless the requirements are very precise. It's a very established system. And finally, we did discuss the 80-20 Moscow rule, where you focus on must-have rather than things which can be delayed, the 20% of attributes which need to be created. And with this, we finish the chapter on project management.